Welcome back. Now we're in part 4, last part. So this is going to have to do with expected value. If you are in cohort if you are in cohort A and you're trying to do this on the remote day, you haven't learned this yet. Don't watch this video yet. Wait till we do this expected value in class, and then come back and finish this after the class. Okay, if you are in cohort A, you learned this yesterday. What we're going to be doing is adding an extra column like we did in class so that we can calculate expected value. So expected value, the formula for that was the sum, so the total of, and in this case we're going to do it as a chart. Almost every time we're talking about a sum in this class, we're going to do it as a chart. X times P of X. It's a weighted mean, right? The weight is the probability in this case. The value is the X value itself. So I'm going to make a column for X, P of X. And what that means is I want it to do my X value. So I'm going to press equals for it to do this, for it to calculate this. My X value is 2, so I'm going to select on 2 times my probability of X, which is that one. And then I'm just going to press enter. And then I am going to fill that down. So again, I'm going to go over to the corner where there's a little box, click, and drag down to there. And then, now, before I start finishing this off, some people think these values are expected values on their own. So some people think the expected value for rolling a 3 is 0.16667. These values actually have no meaning whatsoever. This is just it's the weight times the X. But like on its own, it doesn't really serve a purpose. It doesn't really have a meaning. I can't calculate an expected value of one outcome. That doesn't make sense. You have to calculate an expected value of an entire distribution. Okay, so in order to get the expected value, we need to find the sum. So I'm going to find the sum of that particular column. So the expected value is 7. I'm going to format this. Actually, to format this, I'm going to go paintbrush, and I'm just going to paint it there. Okay. So the expected value of this case is a 7. What does that mean? Well, that means, again, as we discussed in class, the expected value is the weighted mean. It's the average outcome. It doesn't necessarily mean it's the outcome that's most likely to occur. It doesn't necessarily mean that it's the outcome with the highest frequency or the highest probability. In this case, it is. But it's not always. And you might see that in the other distributions that you guys are going to do in a second. So I'm saying it is in this case because 7 is the average. And you could see on our distribution graph that 7 was the most likely. It had the highest probability. Okay. You can start to think about why now that 7 is right in the middle. Why is the average in the middle of this? And that might be hard to answer right now just looking at one example. But when you do it for the other two, I want you to try and start making some connections. Why is the expected value sometimes right in the middle? Why is it sometimes at the highest value? And why other times is it not at the highest probability and it's not right in the middle? Start trying to think about those questions. Okay? So if I were to describe the expected value, though, again, 7 means if I were to roll the dice many, 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 many times, and then I took the average of all of those dice rolls, the average sum would be 7. Okay? It doesn't have to actually be an outcome. This time it is. 7 is possible. But I could have got an average of 7.2. And not for this particular thing, but that's possible. Even though 7.2 isn't an X, because it's an average of those. So if we think back to like the lottery question, for example, the average ticket winnings might not actually be a winnings that is possible. It might not be a prize amount that's possible, but it's an average over all the tickets. This is an average over many, many dice rolls. Okay, so what your task now is to add the XPX column and calculate the expected value for both of the other two distributions. And then, underneath, I want you to write a sentence explaining what does the expected value represent in each one of those distributions. So you should already have your answers from part 3 under here. Underneath there, you're going to say expected value for this is blah, 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 blah. It represents this. And then underneath there, so you should have 6 boxes now. Underneath there, you're going to do 1 box. And I want you to try and explain why. Sometimes your expected value is right in the middle, and sometimes it's not. First thing, just try and think about when is it right in the middle. Which particular of those 3 is the expected value in the middle? When is it not in the middle? And what's special about those graph shapes? And try and put as much information as you can about that right there. And that's the end of part 4. When you're done part 4, you can hand in this assignment. Okay, great. Good work. If you have any more questions, make sure you come to study hall.